In this presentation, we will talk about the integration, connections, and possibilities of TMON. Firstly, I'd like to brush up the topic of statistics a little bit, since there are several tools that also deal with data warehouse type of processing, preparation of statistics, and aggregated data. I'd like to highlight for which use cases we plan to support in the future the handling and support of statistics in case of TMON, respectively its interface, and in which cases we recommend its usage. After this follows the presentation of CEI, Common Event Infrastructure. Let's right away discuss the question why we have chosen this technology, this product, for integrating with TMON. There are namely such tools, as Zoltán already mentioned, the IBM Process Server, that think in terms of processes and use some sort of logging framework. This solution, which is essentially standard but implemented by IBM, is CEI, and we wanted to check exactly that, whether the structures and information, the identifiers necessary for TMON exist in this case, whether the integration can be really done based on these. However, both directions are worth examining, not only connecting from the existing products to TMON, but also what are the methods TMON could use to be able to send such messages. The majority of our clients have background applications or services that use the TMON system, and using two types of logging infrastructure and technology would mean an unjustified additional development in these codes. Meanwhile, we will present the plugin architecture referenced by Sándor, using which we can receive and send messages towards connected systems. And as another example, the SNMP traps will present the connection to a monitoring system that can be, for example, IBM's Tivoli OmegaMon product. Firstly, I'd like to present a brief screenshot how statistics look like. So the summary pane is on the left side of the screen, and the information used by the statistics and the derived ones can be followed through using drill down on the right side of the screen. What would we like to use it for? Since the TMON system has not only the aggregated composite data and statistics, the drill down to the primary data is certainly possible. Besides this, the statistics, in fact database tables and views that contain aggregated information, can be configured, and the interface is built up dynamically, practically from these configurations. So the layout that statistics are on the left side and TMON data on the right side, respectively the build-up of the menus, can be done based on these configurations. Our thinking is to position these statistics mostly for IT-related events. Respectively, we recommend their usage in this area, since the business events can be properly monitored through so-called KPIs, key performance indicators, using among others IBM's Business Monitor tool. However, for those users who use the TMON system, it's obviously much easier if they can follow the events and the statistics on one single interface. What does CEI itself mean? As I have mentioned, this is the IBM implementation of a standard. It's IBM's implementation of the standard related to the web event format of the Web Service Distribution Management Group and the related infrastructure for message transmission, creation, and distribution. The common base event will occur several times during the integration, and I will abbreviate it as CBE further on. This is essentially the simple XML message that is created and sent to the central component as an event by all applications built on CEI infrastructure, including the process server. The central component appears in both concepts. As we have seen in the previous presentations, in case of TMON, this is the build log component. In CEI, this is called event server. The message format is extendable and customizable based on user requirements in both cases. And as we will see, they contain extremely similar IDs in case we are talking about real process server processes or other business processes. It is an important difference, and it is an advantage of the TMON system that although both systems consider the definition of logging information and points a task to be executed during logical design, in case of TMON, we provide, together with the product, a concept and a methodology that not just states information important from a business point of view should be logged to CEI, it is more specific than that and provides a methodology that follows the hierarchy. Besides this, it is true for both systems that they provide a programmer interface for external systems, and messages can be sent using this. Let's try to have an overview how our products are positioned, respectively how the existing solutions that may be seen as competitors at first sight are valued. We can say that in fact TMON, the products built on CEI, and the totality of monitoring products can cover the whole life cycle of software components. Starting from the fact that we can introduce the usage of TMON already during integration testing, we can verify with it the messages transmitted between systems, and as it will result from the reference presentation, many disputes can be prevented by verifying whether the individual systems send the appropriate messages according to the specification. If the system is already in production, then in case of debugging and error localization, we can again use the base functionality of TMON. I'd combine in a way two things: application monitoring and health check. Obviously, the monitoring applications are also able to check the running of software components, whether they are in a running status or stopped. Contrarily, they cannot check the logic of these applications, whether the system will be able to respond if the applications are addressed. However, using TMON, even in production, we request such a ping or a live sign from an application that drives its logic, and we can verify its operability. Let's imagine a transfer. If we are able to call a transfer service with the amount equals 0, this doesn't change the status of the live system. Still, practically its complete logic is executed, and this is a sort of health check. If the application logs to TMON, this can be verified there the same way. Obviously, a periodic repetition of this is needed. However, besides IT level or application level monitoring, the business level monitoring can be included in the life cycle of the application as well. Two systems, respectively solutions, can be taken into consideration here that were built by IBM on the CEI technology. These are the business modeler and the business events. I've abbreviated them as BM and BE on the slide. Obviously, besides this, there are suitable products for monitoring either the operating systems or the application server components, respectively for alerts built on this. These logics are not considered part of the TMON system. However, it can happen that it is exactly a TMON message that should result in an alert. In such cases, it should be considered what integration possibilities could be applied between TMON and the monitoring system. If we'd like to get to know the possibilities of CEI a little bit, then I'll tell you as much about this that there is a programmer's component called emitter, and we can send messages using it. The details of message sending and processing can be set in case of CEI using configuration. These are called profiles. The method can be synchronous. Even a simple database update can be initiated, but for us, the possibility of asynchronous message sending is much more interesting, since this perfectly suits the fire and forget concept, using which we'd like to separate the logging information and the execution of logging from the application logic itself. So practically, the asynchronous message sending is taken into account during integration. In case of filters, we can say that we don't necessarily want to send each message, so this can be filtered already on the sender side. Respectively, the distribution of the messages can separate using profiles or the publish and subscribe mechanism. What are the applications that need to receive a given CEI message? This means that if the processor of CEI messages is TMON, then it's not absolutely necessary to transform all CEI messages into TMON messages. And it's also true that Business Monitor or business events will not necessarily use each message flowing through the CEI infrastructure, only those that are needed. Let's have a look what we can regard as event. Here, for example, these are the process server and the processes. I've drawn a simple process diagram that contains the different dumplings, logics that can be associated to the BPEL technology as activities. Essentially, we can observe that for each activity, the process server creates and sends through the CEI infrastructure the information about its start, end, successfulness, status, very similar information to what we require in case of TMON. We have to clarify one more question, that is, in case of TMON, essentially the strict hierarchy. As the panels are built on each other, and we say that the process steps belong to a given process, similarly this hierarchy can be observed at the processes running in the process server as well. Here we can state that the activities running in the process correspond essentially to the process steps according to the TMON concept. This means essentially that it was relatively easy to fit the structure into the hierarchical system of TMON. We must examine one single question. In case of CEI, the depth and embedding of hierarchy levels does not necessarily have limits. Accordingly, in case of the TMON system, we will handle a sort of flattening of these contexts, since there is no point starting so-called sub-processes technologically in the process server. The events occurring in it will affect the main process, so we'd like to see them on the same level. So we can view the process steps performed in the sub-process in the same place, together with the steps of the main process in the TMON structure. Let's review what was our base concept regarding integration. As I already mentioned, we wouldn't like to put particularly strong restrictions towards existing logging systems, and we would like to reuse the advantages of different technologies and applications built on them, and to create added value through the integration of TMON and CEI. In case we would like to analyze and display business-level information, then we obviously use both technologies together, and in case of monitoring individual events, we recommend TMON. The products and technologies mentioned so far follow through the software components practically through their entire life cycle. How does this architecture look in fact, and what will be in the next release, what we can hopefully present in the form of a demo already next year? We have three main actors: message sources, the logging service itself, and the layer of software components having some sort of display. Message sources can be extremely varied. Existing TMON messages can arrive from background systems, applications, even from the message broker, or practically even from non-predefined locations through the CEI infrastructure. Currently, we mean by this the process server, respectively, as Sándor already mentioned, the tapping of messages. TMON messages can be created by tapping the logs of systems that don't have TMON logging, and these can be forwarded to the central component too. What needs to be done after this? In fact, different logics need to be put in place for processing different messages. We named these configurable plugins. These need to be selected very similarly to the filtering mechanism of CEI based on the content of the incoming message, for example type or structure. The given plugin is activated and makes the incoming message TMON friendly, processable by TMON. One of these can be the CBE transformer plugin that transforms an incoming process server message into the structure of TMON. In the outgoing case, a CEI plugin can be used that transforms the TMON information into a CEI message using an emitter. Obviously, the database importer is practically constantly used for incoming messages. If an alert needs to be sent out based on an event, then the SNMP message sending can also be activated as a sort of post-processor plugin. After this, the respective display applications receive the information only in the format they can interpret, and they are able to function with these. We try to check the feasibility, as I mentioned, whether the messages, identifiers, and structures of TMON can be supported using the CEI message sent by the process server that should be regarded as example in the future. In order to be able to imagine this, with some difficulty, I have squeezed the CBE message on this screen. I've marked the information that is interesting for us with bold, and I've marked with underline the mandatory fields we can count on, not only in case of such a sample process server message, but in case of any message. We can observe the unique identifier of the message, the information identifying the context that we can use for identifying the mentioned process and process steps, the type and identifiers like the different activity names and the name of the process type, respectively the information related to the status and successfulness of the given process step. Obviously, the source itself can be identified as well, and it is a mandatory element of the message. So let's list the possible plugins. I just go through in a nutshell. We can differentiate between preprocessor and postprocessor plugins. It is called a preprocessor plugin if the incoming message has to be made usable for TMON, and postprocessor when some sort of event information has to be sent based on an entered TMON message. It is important that the activation of multiple preprocessors is not allowed. This means that we should be able to transform an external message for example a CEI message, into a TMON message in one step. There are several solutions from a technology point of view. We can choose from them practically via configuration. There's one single question remaining in this topic: the handling of hierarchical contexts. We use the solution in the middle for supporting this. If we leave the contexts out of consideration, it would mean that each sub-process gets into the TMON main process. This way, we would lose the relations between individual processes. In certain cases, it is imaginable or useful that this can be implemented this way, but we consider it much more useful if, in case of incoming messages, the TMON system itself registers all root contexts, respectively their descendants. This way, it can be determined about the incoming message using practically one single question to which context it belongs, and the given message gets represented in the hierarchy system of TMON. Obviously, it would be possible to implement a full reference and status handling method, practically the handling of a database table pointing to itself, but we've referred several times to the performance and loadability of the TMON system, and we think that in case of processing several millions of messages daily, this would cause such an increased performance demand that the added value of this solution isn't really worth it. Accordingly, in our next release, in case of CEI messages, the registration of the root context and the sort of flattening of the hierarchical structure will be supported. Obviously, other cases can occur. It's not necessarily just the process server sending CEI messages to TMON. In this case, we can implement the integration if we work with so-called TMON-friendly messages. This means that besides the mandatory elements, the message really contains the identifiers that are useful for TMON. In fact, we can provide the checklist, a set of rules for this, partly with mandatory elements, partly with extension possibilities. Provided by CEI, these requirements can be fulfilled. As I mentioned, the second direction is the CEI message sent by TMON. This is a perfectly meaningful and useful function, since we can send exactly through this the already existing available datasets, structures, towards the applications using it. See Business Monitor or Business Events. In case of the post-processor plugin, it's worth separating processing from post-processing, since we wouldn't like the processing of the TMON message to fail because of notification. However, besides this, we can say that several plugins can be activated for a single incoming event TMON message. So nothing prevents us from sending both an SNMP trap and a CEI message based on an incoming message, if this is meaningful and requested by the configuration of the system. Finally, I'd like to say a few words about the possibilities of monitoring. We've brought up Tivoli Omegamon as an example here, but obviously we could refer here to any monitoring application capable of receiving an SNMP message. The basic idea here is in fact that the additional logic related to alerts and monitoring, that these software products are perfectly suitable for it and regarded as their basic objective. These functionalities, I think, are not worth implementing again. We put the emphasis much more on a mutual cooperation, and we can send messages through these SNMP messages using a simple API. As a summary, since I'm the last D-Logic presenter, I'd like to summarize again what are the new things that are available in the current release compared to the previous ones? This is an enhancement, bug fixing of the interfaces, which meant, for example, the filter editor, the saving of various filters for several users, the statistics, and the entire functionality related to their handling that can be performed using external configuration. We have seen an example for this in the demo too. The first presentation mentioned the performance optimization that is part of our current J2EE implementation. In case of the figures presented there, we reported the acceleration of the XML processing, and I'd like to tell you that the XML processing represents a significant portion of the entire processing of the messages and its capturing in the database. So we think that this will achieve a serious load decrease on the application servers running the build log. I'd like to highlight this because the topic here is not just that we chip off a little bit lar per lar and we look for thinner algorithms, but in case of huge load, the resource requirements necessary for processing are close to the operational limits. Accordingly, we think that with this implementation, we can further increase the number of messages that can be processed on a given node. This in fact means that the quantity problem turns into a quality problem, and we make continuous efforts to handle this. Eventually, I'd like to thank you for your attention, and I hope that next year we can greet you with regards to TCPS integration and CEI integration as completed developments.